Hi everyone, today we have an important topic in digital logic design and also computer architecture, which is Boolean algebra. Boolean algebra is actually so important to deal with logic gates, and using these logic gates then you can have more complicated components. So starting with Boolean algebra, I would like to introduce for you three important gates. Firstly, AND gate, and use the second input, AND gate, OR, and NOT gate. Starting with AND gate, this is the shape for AND gate. Let me change the color. This is the shape for AND gate, and actually AND gate is working as a multiplication. As you know, like you have first two inputs, or also you can have more inputs as you wish, but for the output it's only one output, and also you can name them whatever you want. So here I have A and B, and Y is my output. So to know how this gate is working, simply we can say that Y equals A times B. And now we're going to make something which is similar to a truth table, because each function actually has its own truth table, and the truth table is some scenarios for the input, and we are predicting the output. So if the input here was 0 and for B was 1, we're going to multiply both inputs, so 0 times 1 will give us 0. So in this situation we got 0. If we switched, so this one then 0, 1 times 0 will give us 0 as well. Then if we had both of them zeros, 0 times 0, we will get 0 as well. So when we're going to get 1 as our input, as our output, both inputs should be 1. So 1 times 1 will give us 1. And also, like I said previously, that you can have as much as you can of the input, like you can have 3, 4, 5. It's totally fine, but to get 1 as your output, all of your inputs should be 1. So this is actually a condition if you want to get 1, but you will get 0 if at least one of the input was 0. Moving to the second gate, OR gate. This is the shape for OR gate, and actually should memorize the shapes, because then you will need them to, for example, draw the circuit for a particular expression, or to change like from the figure, then you're going to write the expression and so on. So here OR gate is working as an addition, like it's basically like an addition gate, or you're adding to the function for this gate is to add the inputs together. So when we are going to have the truth table for this gate, we're going to add them, but here we have something different because this is a Boolean algebra. So let me start with the first scenario. If this one was 0 and this one was 1, so Y will be A plus B, or you can say Y equals A or B. So here we have 0 or 1, so we'll get 1. At least to get your output as 1, you should have one of your inputs as 1. And if you want to get both, if you want to get like the output that has like the value of 0, you should have both input zeros. Okay, so this one, 0 plus 0 will give us 0. And also if you flip these two, like A was 1 and B was 0 and 1, also you'll get 1. But the trick here and difference is if you had both of them, both of one holds the value of 1, and then you will get 1. You can't get 2 because this is Boolean algebra, and in Boolean algebra you either get 1 or 0. You can't get 2. So just keep in mind that at least you have for OR gate, to like the condition for OR gate to get the output as 1, you should have one of them, one of the input as 1. But for AND gate, you should have all inputs as 1. Okay, and the third gate is NOT gates, and this one always change the value. So if the value of the input was 1, the output will be 0. But if the value of the input was, for example, 0, you will get 1. And now we're going to move to Boolean expressions and how you can translate them or draw the circuit for this expression. First of all, you can see that here we have the sign for the negation or NOT gate. So we're saying NOT B. So we're going to have NOT gate, and here is B. Then A and B are ANDed together. So we need AND gate. Taking this output, and here the output for NOT gate is the input for AND gate, and we need another input, A. Then we have here C, and we're going to OR them together using an OR gate. And then you can like name the output whatever you want. I'm going to say it's Y. So this is the first expression. Moving to the next one. First, you're going to start with the brackets. So here we have a curly brackets. We're going to start with them. We have C and D. They are all together. Then they are ANDed with A. So here we have an AND gate and A. Then we have NOT gate. Also we have B and E, and they are ANDed together. As you can see, like here is like we are multiplying them together, so we need an AND gate. Here we have an AND gate, B and E. Then we're going to take the output for this gate and OR it with this gate for the NOT. This is an OR gate, okay? Here we can say that the output will be Y. And that's it for this video. Thanks for watching.